Welcome, everyone. This is our Innovation X Roundtable on Advanced Manufacturing and Industry 4.0. So let me introduce Professor Itlaq Sidhu, who's the founding director of the Sutarja Center for Entrepreneurship and Technology at UC Berkeley, and its chief scientist. So Itlaq, please go ahead and kick us off.
Okay, great. All right, thank you. Definitely welcome to everyone. As Keith says, welcome to the Roundtable on Advanced Manufacturing and Industry 4.0. So we host these Innovation That Matters Roundtables. It's a series. It's hosted by the Sutarja Center for Entrepreneurship and Technology. I am Itlaq Sidhu, the director and chief scientist for the center. And to help set it up, there's a couple things that I want to explain. One is kind of the background context. And so just on that topic, there's definitely a lot that's been changing the world, both because of the health conditions, the change in the economy. There's a lot going on in terms of just what we consume and what we do differently these days, but there's also geopolitics. There's the overall change that's been going on in manufacturing and supply chain anyway, even independent of all of those things. And somewhere in there, there's a whole different set of industries that are emerging and what those new supply chains are going to require. There's questions about talent, and all of these issues are part of what we're going to be trying to understand today. Now, the second part of what I need to communicate before all the roundtables is that in addition to understanding the topics of where manufacturing is going, the other thing that we'd like to do with these roundtables is make them useful to Berkeley and to make them useful to Berkeley students, as in they are a type of mini advisory board session. So our distinguished panel, as they discuss these things, we're going to be listening for how can Berkeley and the Sutarja Center best engage in this topic, and how can we collaborate with partners, academic partners, industry partners, what should students be doing, all of those types of questions. And so we'll, by the end, try to get a little bit of feedback in that direction. And in order to help everyone, including the panelists, I'm going to put up one slide that explains what the center does. And with that, we hope that the feedback that we get at the end will be the most effective for the overall purpose. So UC Berkeley Sutarja Center, our mission, and center was started in 2005. Over this time, our mission is to empower innovators to positively change the world. And there's three categories of things that happen at the center. One is we have a set of courses which are largely around the words Berkeley Method of Entrepreneurship. And what happens in these courses is that while people are working on their ventures, we are also working on developing the psychology, the mindset, the behavior that's inside that person. So mindset, behavior, how teams form, all of these topics are inside the class while the new ventures are being developed. A second category, that's the one on the left, second category is what we do with innovation engineering and with our X labs. And these are all what I'm going to roughly call collider types of courses, where a lot of different people mix together, and that they're typically a lot more technical and a lot more implementation focused. So we have things, for example, in Data X, which is applied data science with venture applications, companies, students, global partners, they all mix their, companies bring their projects, their topics, students bring their skills, sometimes people bring data. We're doing a lot of mixing and doing projects that couldn't be done necessarily by any one of the parties. Blockchain is another area, plant-based meat. We are doing projects in 5G and AI with all of the telephone companies around the world. So anyway, there's this category of innovation engineering and X labs. And the third bucket here is how we're engaging with other universities around the world and how we're engaging with industry. For example, on the industry engagement, we have a engineering leadership program. In this case, people from Apple, Google, Yahoo Network Appliances, Samsung, Cisco, Verizon, so forth. Like many companies send people and now send by Zoom, frankly, to a program that's one night per week. It's really for technical people who would not get an MBA, but would benefit from the network and from that kind of broadening focused around innovation. Anyway, these are just examples so that everyone on the panel also has some context about how the things you're talking about can relate to the types of things that we can be doing in future. So with that, I'm going to basically shut off the share. I'm going to turn it over to Ryan Kelly from the Association for Manufacturing Technology to lead the panel. I'm really pleased that he's willing to spend the time and to lead the panel. And I'm really looking forward to the conversation from all of the distinguished panelists. Thank you.
Thanks so much, Iklok. And it's great to be here and to see all of y'all as we're gathering here on the internet during these very strange times. So pleased to have our esteemed guest with us today. My name is Ryan Kelly. I am the General Manager of the Association for Manufacturing Technology's San Francisco Tech Lab. And we're joined by some really interesting people. I'm going to allow them to introduce themselves, but I'd also like in their introduction for our guests to explain a little bit about what the future of manufacturing looks like from the point of view of what they do in their jobs or they are seeking to do in their careers. If you're wildly successful, how would manufacturing change? Let's start with Megan.
Great, thanks, Ryan. And thrilled to be joining my fellow panelists. This is a really amazing group of folks, as Ryan mentioned. So my name is Megan Brewster. I am Vice President of Advanced Technology at Impinj. Impinj is advancing the Internet of Things and innovating ways to bring all things online. So our vision is boundless IoT, trillions of everyday items from apparel, automobile parts, luggage, shipments, all connected to the cloud. And so our platform delivers that connectivity for everyday things and enables the development of IoT solutions. So for us, for Impinj, the future of manufacturing is where supply chains in every industry are ultra efficient and have the ultimate visibility of every item, which I'll talk a little bit more as we get into our discussion. And personally, where I see the future of manufacturing is, diverse lived experiences and backgrounds that are fusing with manufacturing lessons. So for myself, I actually got into manufacturing through the federal government. I'm a scientist by training, but I took a little tour of duty through a fellowship that puts scientists into the federal government. And that's how I ended up at the White House Office of Science and Technology Policy, where I oversaw the advanced manufacturing portfolio. And that's when I fell in love with how we make the items that we use and consume every day, both the technology that we use, but also the workforce that makes that happen.
Excellent. Cathy?
Right, so I'm Cathy, I'm from Thomas, I'm the head of audience. Thomas, we are a data and technology platform, thomasnet.com. On a monthly basis, there are around 1.5 million visitors from all industrial sector. I always say from Raytheon to, the Ministry of Defense, Boeing, Tesla, they all come to us to source suppliers for the innovation and production. So, but we are also a company that has been around in America for over 122 years. So we learned a lot about what innovation means. And in the context of me, you may hear that I have a bit of a weird accent. Born and raised in Hong Kong, had my education in London, moved here 3 years ago. This is my first in-person presidential election. It is riveting, but I am not going to spend too much energy on that. I wanted to talk about a bit of a European kind of Chinese background in seeing manufacturing and the future of manufacturing. I think what's really interesting is if you look at all the country leaders for America, Europe, and China, we have mostly lawyers here in America. They kind of graduated and became lawyers and then run the country, become politicians. And in the UK, they are mostly, policy, economics major. But what's interesting is most of the prime ministers of China, they're all engineers. So growing up in Hong Kong, we're always told the 4 biggest and most important professions are either, you grow up to become a doctor, or you become a lawyer, then engineer, or you run businesses. So engineering is actually the 3rd most important capability as valued by, being Chinese. And I think what is interesting is Ryan and I had a lot of long conversation about the future of manufacturing. And I think my dream is we'll all work together in this country in building a vision, a blueprint, so that we understand in the next 2 decades, what are we really investing in for the talent that we need to cultivate? And also really trying to draw a parallel between all the greatest innovations in startup and technology and understand that all those concepts like lean manufacturing, we're talking about agile product development, they all are inspired from manufacturing, but also, people that are on the call right now, if you're thinking about, oh no, I'm right in the middle of a pandemic, how am I finding my career? I wanted to tell you, it happened to me when I graduated from my second, 3rd degree. It was during the financial crisis. This is actually the perfect moment for you to really think about how can I jump into a sector like manufacturing and innovate, because your innovation today is going to help make the world a better place because you're making physical products. Whereas if we look at a lot of the startups, I sometimes say a lot of them are parasitical technologies, like, social media, we're looking at how it's backfiring today. I can talk for another 5 minutes, but I'm going to stop for this. I'm just excited to be here today.
Yeah, we'll circle back around, but it sounds like what you're saying is that, the future of manufacturing to you is one where manufacturing is actually seen as central to our lives as it actually is. Jay, please introduce yourself.
Great. Thank you so much, Ryan. Also really excited to be talking with everybody on this call. I think we're all going to have some really different viewpoints on this. Maybe not disagree, but maybe at least poke holes in each other's ideas. So I am coming from Autodesk, and Autodesk, as you know, makes many design tools specifically for architecture and construction, also manufacturing, also media and entertainment. Inside of Autodesk, I specifically am on the technology centers team. And the technology centers are physical sites where we have a vast array of equipment, everything from industrial equipment to hands-on equipment to prototype, test, research, and develop. We support both the internal research teams at Autodesk, as well as a really robust residency program through our Outsites network. Through that program, we have a few hundreds of participants, a few hundred companies, educational institutions, and startups that come to our facilities to do their prototyping and testing, but also because we support this larger community so that those teams can connect with each other and really develop mind share as a community around the future of manufacturing, the future of architecture and construction, future of design. It's really dynamic space inside of Autodesk. And because of that, and because of my role there as part of the manufacturing engagement team, it's very difficult to answer what do you see as what does the future of manufacturing look like? Because it looks like so many different things at once. And so many of those glimpses, I would say, are really exciting. My background is, my training is in architecture. My background is also in furniture making. And I started with the technology centers to build out the physical equipment space in San Francisco, develop our training curriculum, manage the technical team that runs that equipment. So I often come to these questions with a perspective of the technology, the hands-on processes, and what it means to make things. And so when I look at that question, what does the future of manufacturing look like? What does it unlock? So many possibilities, starting from the machine and equipment, how we access those machines, what we make, how we make it, and how we really can address the bigger questions through that process of how we make our world. So in manufacturing, thinking about things like sustainability and how that gets, the definition of which gets turned into manufacturing lingo, like efficiency and reduction of material use. There are so many exciting possibilities. I'm ready to hash it out with everybody else on the call.
We'll get there through the course of this conversation. And I think, definitely it sounds in some way like you're bringing a very Autodesk point of view of this, which is all about sort of the speed in which we get from idea all the way through a physical product. And yeah, so last but not least, Saifu, please introduce yourself. Tell us a little bit about what you do and your vision for the future of manufacturing.
Yeah, first of all, this is a really cool panel. I like all of you people already. It's awesome. But yeah, my name is Saifu. I work at a company called Zometry. We're a B2B marketplace in manufacturing. We connect engineers from a lot of different industries, be able to give them quotes super fast and connect them with suppliers. And kind of underpinning a lot of our technology is a network of machine shops. And that's really what kind of brought me to manufacturing. My background is in user experience and web development. And it was like 2015, I was working at a marketing agency, and my dad, who moved us all here from Indonesia when I was really young, kind of looked at me one day and was just like, hey, look, I'm glad that you're happy working on this stuff, but you're not doing anything important, which is one of those things that like immigrant dads tell you, and you're like, okay, fine, I got to go figure something else out. And that's when Jura from Make Time, and Ryan and I worked there, like almost a lifetime ago, came to me and kind of sold me on manufacturing and how vital it was to the US, and told me the story of, one of his family members who owned a machine shop in Henderson, Kentucky, and how this really skilled person wasn't getting the work that he needed because all of the engineering, all of the ideas, all the products were on the West Coast. And like his mission was to kind of dissolve the geographic barriers that would prevent somebody who was incredibly skilled working in a small business in rural Kentucky work on incredibly important, vital products. And that kind of mission has sort of driven me through, Make Time and Zometry, and spending the last year thinking about machine shops and these small businesses that are incredibly skilled workers that, especially now with COVID, are needed to be treated like essential businesses and be connected to incredibly important work that I think has helped not just this country, but a lot of countries kind of survive the pandemic. That's the kind of stuff that I get really excited about. And so when I think about the future of manufacturing for me, with my background in user experience, I think about it as like the future of manufacturing is accessible, user-friendly products and services that small and medium-sized businesses can use to do work in connected, distributed, and integrated ways.
That sounds maybe not so ambitious, but the reality is that is so different than what it really looks like today. And I think to kind of push the conversation, and then I'm going to kind of back off. I'm going to sort of chum the water and then let the sharks kind of, go at it in any which way that they like. What are some of the problems that you think that sort of our audience members and just the public in general should be more excited about? Like the really interesting, difficult to solve, but also the ones that are going to have real step function type impact on manufacturing, and maybe even by extension on our lives as individuals, as consumers. One thing, and this is sort of listed in the summary of the discussion that we're going to have, is the fact that there's all of these technologies that are set to disrupt, whether that's additive manufacturing or AI or the Internet of Things, but we just don't seem to be quite there. And so I want to maybe train the conversation on that too, of the things that are just like this close, but just slightly out of reach, that are super exciting. And what are we going to need to sort of just set them loose on the industry?
do you want to go?
Someone's got to go first. So it's just, you know,
I went first last time, so it's someone else's turn.
just jump
I'll
right
jump
in.
I'll jump in. I realized in my excitement, I forgot to tell people that my first career choice, I was an academic and I studied Wikipedia and how social trust and technology can actually create the world's biggest free commons based peer production. And it really enabled the democratization of knowledge. So my dream for manufacturing is actually along the same line. Wikipedia inspired me to go into tech and information. And actually, I am working for Thomas, but I am still working in a tech and data-driven company. And I'll give you 2 examples. But the very short way to answer Ryan's question is manufacturing is the route to improving humanity and to use your knowledge to make the world a better place. So the 2 examples, I'll give you the one basic example from Thomas and something that's more startup sounding. Number 1, you guys have heard of Detroit and that a lot of the car manufacturing got outsourced many, many years ago. And thomasnet.com is a platform that actually allow a lot of industrial buyers to find companies. And we didn't know, but there is a paint shop that was about to close their shop right around November. And they have to fire over 200 people, which means that by Christmas, 200 families would have no income. And one of our sales reps stumbled upon that shop, didn't know what kind of pain they're enduring, and say, hey, you can use our platform. Once you put your company there, people may find you. They may send you a request for information. And believe it or not, a lot of manufacturers today still do not know how to put together a basic online catalog or build a digital website. And within the first few weeks, they got the biggest paint shop request from Nissan. And they actually could open their factory, stay open, feed 200 families. That's the power of connecting data and people. And the other example is COVID-19. So Ryan and I actually met online because of COVID-19. He sent us an email saying, what are you guys gonna do? We're not having enough PPE. And overnight, Thomas completely pivoted. We created a category on PPE related response suppliers. We put up a form and asked North American manufacturers to tell us if they have PPE production or distribution capability. Over 6,000 companies volunteered. I feel emotional talking about this. 20,000 RFIs have been sent. Like, people get really disappointed about the world, especially, I mean, I'd imagine you guys are in school graduating, the world seems chaotic, but there are a lot of people who are at the forefront of innovation. And when you make good things physically, you can actually make the world a better place. So I'll stop.
Yeah, I think that the point that you made about like the democratization of information is like, especially with your background in Wikipedia, is like a good one. Like when I think about how easy it is now to get the information you need to become like a web developer or a UX designer, all that information is free. There are boot camps everywhere. It's so easy and accessible to get started in that kind of career. And I think that's why you see that like upswell in that industry, but that's missing in manufacturing. If you go if you go to like the ASC website to go look at those certifications, like those websites it's kind of hard to understand like why you would even like want one of these things in the first place unless someone pointed you there. And I think that's like a missed opportunity to kind of bring people in and get them excited about like joining the industry.
I'm just going to start jumping in so that we, so we're not as so much mute and off mute. But yeah, Saifu, just to piggyback on what you're talking about. I think, especially when it comes to physical make processes, equipment, machinery, there is this incredible amount of embodied knowledge and wisdom that is out there on the factory floor in manufacturing for people who've been working on these machines for decades, who know how this equipment runs inside and out. And we are talking about this like sort of connection between that physical layer and then this digital layer. And I think that connection point is, one of these big thorny problems. How do you bring that body of knowledge into the digital tools in a way that is accessible and understandable and doesn't require a 3-year, training program as an intern, learning all those tricks about that one type of wrench that works with this specific, calibration process, but how can we start to integrate, sort of upstream that knowledge that is on the factory floor now into the design tools so that, when I make this design decision, I'm actually going to have implications downstream that say, now I need to reset the bed size for this particular part of my process. And that's going to, open up this opportunity for more mistakes, less mistakes, whatever. But I think there's this kind of, how do we connect the digital layer and this physical layer inside of manufacturing? And to me, that's part of this, what's very exciting about it, because there is so much opportunity in that zone right now. I think part of what we're bringing up is that there's, like, I think we are all seeing, like, the possibilities are huge, and there are all these entry points, and like, please jump in and start doing things that are going to, change this industry, because there's so many places to do that.
I think you highlighted something that I just wanted to like underline, which is that like the point of the technology, the point of that automation is not necessarily to make people irrelevant, but to help like enable the part of people that is like the most valuable thing, is that we're good at solving complex problems. And I think that's something that, like, when I think about the technology we build, it's not about making people irrelevant, but about letting them focus on the part that, like, what I think brings the most fulfillment, which is seeing a problem, being able to solve it.
Yeah, I agree. I think democratizing that tacit knowledge and know-how that lives with all of these manufacturers, I mean, it's incredibly difficult to transcribe and translate that knowledge. It takes a lot of time and effort to learn those skills, but there's a lot of really exciting tools, both on the hardware and the software side, and especially at their intersection, that I think is doing this. Pulling together a few of these threads and what's going on with COVID, I wanted to share one example that I participated in recently, I think is really exciting. It's a group called Open Source Medical Supplies. So when COVID hit, as we all know, demand for PPE soared seemingly overnight, and supply chains were struggling to keep up with the demand, not to mention all the other impacts from a global pandemic, like closed borders and sick workers. So what OSMS is doing is collecting open source blueprints for common medical supplies and then publishing those to support local manufacturing. So any community is able to go to their website, download these blueprints, and then get started. And so that local manufacturing, it could be done by small manufacturers, but it could also be done by individual makers. And the tools available to those individuals, it's been really interesting to watch as communities have galvanized to figure out, like, okay, we need to make masks. In order to do that, we need sewing machines. Okay, we need to make face shields. In order to do that, we need a variety of ways to cut through plastics of various thickness. How can we do this if we have a maker shop? How can we do this if we have, a relatively well-endowed small machine shop, and all of the different tools that go into that. So I think it's really exciting. It's kind of similar to what Saifu is doing with Zometry, and also with what Jay is doing in terms of democratizing tools at Autodesk. And I think in this case, we found that the competitor in this circumstance, it's not another business or another country. It's definitely the virus itself. And it's our ability to share that information openly, recognize that, this is something that's going to benefit all of humanity, and it should be open source.
I want to just pop in and say that, upon asking the question, maybe I'm not surprised, but maybe some of our audience members are surprised, because we're actually talking about pretty basic stuff here. We're not saying, like, we're just going to beam objects into existence using lasers or something like that. We're talking about things that, if you look at other industries, have been done maybe decades ago. So what's with this? Why is it so hard to do some of these things, and what's really standing in your way? I mean, if you're talking about being able to connect, codify tacit knowledge, right? Getting people on the internet, sort of merging all these sort of disparate things of information into sort of one more useful thing. That doesn't seem that hard. Why is this what we're talking about as some of the hard problems to solve, and how can we actually solve them? Because they don't seem that far off.
I feel like manufacturing is one of those industries that's like, it's so old that when you're in college and when you're thinking about your career, you don't hear about it. And so I like what I see is like all of the people that graduate from these like computer science programs, they want to go to Google, they want to go to Facebook, they want to go, you know, to Amazon, they want to go to these big companies that are top of mind. And so I think a lot of the talent pool gets shoved into those industries, and somehow just like, I guess the marketing or awareness for manufacturing isn't such that those people look at manufacturing and go, how do I build a product in this space? I think that's like starting to change, but that's kind of like the uphill battle that I see us facing. For like all like the developers and designers that work at Zometry, a lot of times this is the first time that they worked at a company about manufacturing, and they kind of just like happened upon it by like happenstance. But then they get really excited about the work that they do once we're here, and they get really connected to the problems that they're solving.
Yeah, because it's exciting and the problems are juicy.
Right. But you don't know that. You don't know that until you're in.
And the problems are real. The problems are a real object, and those objects inform how we live in the world. Those objects tell us something about ourselves. Those objects are designed in a specific way for specific people, and the solutions are a change in what it means and how we live. And I think in that sense, you said the problems are juicy. They're real. And I think on an earlier call, we were talking about that kind of empowering experience that you have when you actually make something in real materials that ends up in the world. And that I think if the image and the experience of that can get in front of folks who are looking at things like computer science and developing digital tools and data analysis and all of these skills that are going to be absolutely essential for Industry 4.0, if we can get that experience and that process out front of the image of the jumpsuit and the steel-toed boots and the greasy wrench, I think we can talk about and construct the future of manufacturing in a different way, because we will have different people coming to the forefront. But and I don't want to discount the power of the jumpsuit, because I think we talked about it before. They're awesome. Manufacturing leads to jumpsuits. I think we should make that clear on this call. But really that the empowering experience of impacting our built environment through manufacturing, that is, I think, what brings us all to the table.
Yeah, I think also one of the challenges with a lot of these technologies is it is a big upfront investment cost, both in terms of infrastructure and fixed infrastructure costs, but also in terms of learning and changing processes. And change is hard. For individuals that have been going through a particular process, to change that to a new digitized process, even though it will pay off in the long term, the ROI is going to, go positive within 3 to 5 years, it can still be really challenging. So one example that I'm really excited about with the technology Impinj works on, which is a passive RFID, is that RFID can enable every industry to be more efficient and less wasteful, which is in fact the heart at some of the world's biggest problems. So for example, the one that I'm really excited about is food insecurity. So both from hunger and foodborne illness, at their heart, these are logistics problems. And part of the reason is because it's incredibly hard to trace exactly which batch needs to be recalled as that batch of perishable food items is moving through the supply chain. And right now, the food industry is predominantly using barcodes, which require line of sight to read. But if you're able to move to RFID, it's almost like an invisible barcode. You don't need a line of sight. You can just almost instantaneously digitally read all of the items that are in your inventory. So you can imagine the power that brings in terms of tracking and tracing individual items as they move through the supply chain. But the transition, even though these tags are incredibly cheap, it still requires that upfront infrastructure investment, and it requires that change management at the human level in terms of the processes that these companies are working through. And I think that that's something that all technology developers need to be thinking about. How do we make these technologies easy to use and easy to adopt?
And I'll just add to what Megan and everyone's saying, really. I mean, there is a problem with manufacturing that I felt like the startup community, they have already solved for. Data standardization and blueprint standardization. If I saw Greg, one of the participants, attendees, ask a question about, hey, I work as an engineer, and there are a lot of different types of defining CAD drawings and engineering measurement tools. Like, not every company has the same standard. I think looking at Thomas, we have over 70,000 categories of products and supplies. And Brian and I are just working with different organizations to see how we can speed up the standardization of manufacturing ontology, right? Like, if we have more shared understanding about materials and objects, we can share knowledge faster. But it feels like there isn't like a big driving force. I'll give you two examples that are in the startup world. Facebook with their open graph technology. Every single website has it enabled. If you click on something is a pair of pants or it is actually a celebrity, right? And Google with their search engine, they push their Google search schema. If you're in SEO optimization and your website has not actually labeled in metadata what your content is about, you are not going to be seen by Google. What is that equivalent for our sector? I do believe once we solve for that problem, then our speed of innovation will grow exponentially. Yeah.
Yeah, something that I'm interested, like, I don't have an answer to this, but those technologies that the two of you have highlighted, and I know Jay's probably got like 20 more that she's thinking about. How do we bring that to a machine shop or a small business that is going to be super focused on staying in business? There was like a study by, I think it was JP Morgan, that looked at cash flow for small businesses, and the thing that they found was that on average, a small business is like 10 to 15 days away. If their revenue all dried up one day, say that a pandemic hits, they're 15 days away from not being able to keep the lights on anymore. And so how do we bring like those technologies that could be cheap but have that upfront investment, but make it accessible to people that could benefit from that the most, but don't have like the time or like the understanding or are just worried about other things and giving that to them?
One of the things that I'm seeing is that the tools are becoming just very quickly becoming more accessible. So where, previously you would have an MES system with a systems administrator, and that would be their role. I'm seeing MES systems.
And you bought it for $75,000 to $180,000. Yeah.
Yep. Yeah, now there are subscription MES systems that operate like apps that you can configure on your shop floor and so that's a distributed tool now that you have, many individual operators contributing to, and you don't need a data analyst to tell you, what you should be looking at in terms of productivity or efficiency. So I think there's also a really interesting overlap between industries where we see things like, virtual reality or mixed reality coming into manufacturing and supporting things like tool maintenance or preventative maintenance, where you can take an iPad into your shop and look at what needs to happen here based on what your MES system is telling you about, predictive maintenance. Now you have a tool that could go in and actually guide you in doing that maintenance. Seeing the same thing happen even with PCB board verification inside of the manufacturing process, where you're using a digital overlay, where I think because a lot of these tools are becoming subscription based or they're becoming services, they're also becoming more accessible. They're using some of these emerging tools like XR. That I think that the barrier to entry is actually coming down on a lot of these. We might not be there yet because some of the other stuff you've brought up, Cathy, too, is that we are missing standardization in a lot of places, and that's still a big hurdle. Even the data format coming off of our CNC machines, we're looking at a number of different formats and trying to get some standards off the ground there. But it's not it's not, quite as exciting an area as talking about the emerging technologies, but it's really fundamental to enabling transfer of data across, sites, locations, tools, analysis, and it's going to be a critical step. Yeah,
I agree with that, and our organization is actually behind, contributes to, but also is sort of behind some industry standards like MT Connect, for example, which is a sort of the machine-to-machine communication language that's used in manufacturing technology. But it really seems like standards get adopted because people need them, and so it's kind of like a chicken and egg type of scenario. I wanted to sort of shift the conversation a little bit to the fact that COVID, if there's a silver lining here, has really put more eyeballs and made people care about supply chain and manufacturing more. Do you guys think that that's enough of a push to sort of to have us overcome some of these obstacles? And also, if it's not enough, what can we do to sort of keep this enthusiasm? What can we do as sort of as an individual, as companies, and as an industry to say, we are important, we really affect your lifestyle. You like toilet paper? Manufacturing does that.
I think we could probably agree everybody's a fan of toilet paper.
Yeah, and I think, kind of building on what Jay was saying earlier, the democratization and barrier to entry for a lot of these tools and skill sets to make these everyday items are coming down. But some of let's assume that problem is solved. So then working your way further up is then, what are the problems that are worth working on? What are the problems that need to be solved? And I think that COVID has highlighted some very important problems that, it's not necessarily rocket science to solve some of these problems. The technologies exist. They may be a little hard to get a hold of. They may require some upfront investment in terms of time and learning, but you can get there, and that barrier to entry is reducing. But understanding what are the problems that we should be working on as a society, what are those grand challenges, I think are is really important. And one of the things that I thought was really interesting, I did some work on crowdsourced product design, and I just think the overall model of crowdsourcing solutions to problems is a really interesting way to shine the limelight on problems that need to be solved, and individuals are able to come to that table. Anyone can participate and choose to help solve that problem. It's up to us to identify what are the problems we're solving and which are the ones that we want to work on, or which are the ones that we have a good skill set, it's a good match to work on. But it does democratize that ability to be in the room to solve the problem. So at Launchforth, we would run global open design challenges. And then in that case, the solution to the problem was generally a consumer product. But you can run obviously other kinds of challenges. But what you would get is just this huge diversity of solutions that would be informed by the lived experiences of those designers. So that, the idea is that diversity and inclusivity of the solutions is also somehow built in to how that problem was solved. It's not foolproof, of course, but it's moving in that direction.
And I'll also jump in. So what Ryan asked is, will the appetite for reshoring increase? And we've been doing Thomas Industrial surveys with interviewing over thousands of manufacturers. The answer is yes, definitely. 2 in 3 manufacturers in June said that they're really interested in reshoring. But the question is, our industry is so vast, from healthcare to food to energy. There are different levels of inertia when it comes to bringing businesses back domestically. What is interesting, I think, is I'll go back to the data point. I think if we have more strongly, unified certifications that can show supply chain transparencies for important sectors that are important to the national health of this country or security. Like, there's no reason why 80% of our PPE should be all manufactured overseas, right? But it was like that because of cost. So I think it cannot all be a bottom-up solution, just like Daniel's asking all the panelists, like open source professionals all compensated for their time and energy. Some may do, some may not. I was talking to Helpful Engineering. They have 18,000 engineers from around the world, and their head said, yeah, the organization is a bit burnt out. They have been working, some of them with a full-time job, doing this part-time, trying to drive it forward. So they came to Thomas to see if we can speed up the kind of speed dating thing between manufacturers who could prototype their design. But then you run into two problems. Number one is a lot of manufacturers can be struggling a little bit with the current economic climate. So they might not have a lot of financial bandwidth to do prototyping without promised financial gains. And then you also have a liability problem. So a long and short of it is I'm totally, completely for open source, but I also feel like we probably need more backup from the government or any public funding that can really help us bridge that gap. We need some top-down support as well.
Okay.
Sorry, did I just kill the conversation?
No, you didn't. We were Iklak was about to jump in. We're all
okay. Yeah,
on the edge of our seats here.
Okay, yeah, I wanted to jump in, but I didn't know if this is the moment I was supposed to jump in, so that caused the silence. However, the point of jumping in is I got a lot of great highlights from this conversation, and actually let me just kind of list for you a couple of the kind of headlines to the things that I think that you've brought out. Starting with, the value of connecting people and companies. There was a comment about robots versus people, and you started to address that. You brought up open blueprints. You brought up recalling, just simple problems like, not simple, but necessarily, but problems like recalling batches and defects, and what does it take to do that? The idea of the parallel of the Google SEO tag, so that you can again make a lot of this manufacturing more interconnected. Democratizing manufacturing was another kind of topic you brought up. One of the audience comments was, what about the slim margins, and how does that allow for these changes that are necessary to happen? And I think towards the end, you're really talking about supply chain transparency. So you got a lot of, really great points. And I think if you look at all those points as a collection, I get a theme for the whole conversation, in terms of where you think the issues are. The question I have in the last, 5 minutes or so, 8 minutes, whatever it is can you, orient any of those things for what Berkeley or Berkeley students should be doing, partnering, thinking about, collaborating on? I'd love to get that kind of feedback from the panel in this last round. And that's always a hard one.
One thing that I'll just go in, and this might help kick things off, is the fact that a lot of the easy problems have been solved, and it's a great place for institutions like Berkeley, and especially the center, which by definition is multidisciplinary in nature, right? It's not about bringing some kind of spot solution in. It's about looking at this as a system and saying, oh, how can design thinking help? Or how can computer science help? Or how could someone that's really good at designing algorithms help? And it's going to be this multidisciplinary approach of reaching farther that I think is going to help us gain the most, because manufacturing, with its sort of background in lean, it's very familiar and comfortable with incrementalism. What needs to happen now in areas where institutions like Berkeley can help is say, let's swing for the fences on this.
Mm-hmm.
So
yeah. Oh,
yeah,
sorry. So building on that, I think it's really interesting, as you were saying, to take lessons learned from one industry and apply them to a totally different industry. So, you know, and we've talked about that with a few examples already. One that I've seen that's particularly, I'm really excited about, and, you know, full disclosure, I participated in this, is where we've taken lessons learned from manufacturing and we actually applied them to government and policy making. So in this case, we took the process of product design and prototyping, and then we adapted that. Instead of applying it to hardware or to software, we actually applied that to government policy making. How do we prototype policies? And we actually did this on the policy topic of the future of work. And this was done with colleagues from IDEO and Harvard's digital HKS program, where we applied IDEO's design-driven process to prototype policy solutions. And I think that this could be applied to any of these big thorny problems that are multifaceted in nature and very complex. And in this way, we found that through the prototyping and design driven process, the solutions are inherently interdisciplinary, they're human-centered, they're inclusive. And I think the part that I personally was really excited about is that they're built to test immediately and iterate rapidly. That's part of the policy solution. So I think that's just one example of that, that fusing of disciplines.
Okay, I got that. I mean, both like one industry to another, but also the idea of using design processes for manufacturing itself. Do you have a favorite industry that you think manufacturing could look to for parallels as what they could be doing in a different plane?
I was actually typing to add to Terrence's point. If you look at startup community, there are many amazing incubators, you know, from Y Combinator to many, you know, angel fund seed round. You know, people are very willing as private sector to put money in embedding for future for innovation. So I do think for manufacturing, ours is a branding problem. People thought, you know, when it comes to manufacturing, it's people in the shop with tools. That's true too. But some of the ventilator people invented, they are powered by Raspberry Pi code, or we're using Python to do automation analysis. It's not that different. Like, why can't we build that sort of culture into manufacturing and encourage private sector to really invest in the future of manufacturing, like tech startups?
That's something we could definitely kind of do directly, because we work on innovation culture broadly to start with. So I'll just make that internal note.
Okay, let's do it after this. I'm free at 4.
Yeah, I think there's a lot of,
that's why we hold these roundtables. Yeah.
Yeah, I think we identified a lot of friction in manufacturing, and I think when people are able to focus on specific, unique friction and have an opinion on how that could be solved, that's where you can see a lot of innovation. To be able to focus on one specific friction point for, you know, a year or 2 years, iterating constantly through that, I think that becomes really powerful. I think there's a lot of space in like fintech and financial services and kind of the lessons learned there about how to make complex things like funds and how money moves and things like investing and making them simple for people to jump into. I think there's a lot of space in manufacturing for that too. You know, kind of what Megan said about things are cheap, except for the point where you have to do the upfront investment. How do you make that part? How do you reduce that friction for machinists and for manufacturing?
Yeah, I'll jump in. I think I'll bring it back around to the hands-on. I really see a huge opportunity in carrying on the thread that's been brought up here around bringing more diverse viewpoints and perspectives and disciplines to the table to develop the solution. And I think connecting that to the hands-on experience of creating this built environment, whether that's working with the tools or whatnot. But I think that there is that is the space to me that remains the most exciting, is how do you connect the diversity of thought, approach, discipline, and technology with this existing equipment. And we have a lot of legacy equipment out there on factory floors that is really impressive, really efficient, been honed over many years, and how can we bring the connection between those two? I think that is that there's something very valuable in having the background maybe in computer science, but also having tried to run a CNC machine before, or developed one part in your hands, and then having those perspectives collide opens up that space for imagining what's possible in a new way. But I agree with what's been said here around bringing diversity of thought and practice to the table for developing those solutions, and experimenting in some more broad ways that are accessible.
De-risk it too, right?
Yeah.
Experiment with smaller risks. That'd be, I think,
in parallel with all of this, and we really are kind of closing up here in terms of the timing, but in parallel with this, one thing that we've been thinking about, or I don't know if we've all been thinking about, I've been thinking about it, literally all on this call, is that this entire, like all these roundtables that we're holding, and this one, as like a prime example, could really be the basis of a course. And we can take this video and other videos from the roundtables, and this type of experimentation, like by listening to this and then using that as a basis for all the ideas and student projects, we can go into both connecting companies, but we can also go into what are those kind of broader ideas and swing for the fences, and what are the new models. Those can be developed just as touchless society, or just as future of payment, or just as like other future of telecom with 5G. I think these are all kind of tracks that could be in a Innovation X type of course, basically the name of the roundtable here. Hopefully you like that idea, because if you do, you're going to be part of it one way or the other.
I'm sorry, I'm smiling because the chat is riveting. Like so many great conversations going on. Oh, I don't want this to end.
Okay, all right. Well, then I think we've done something successful and good. So with that, we're at 1:01, a minute past. But I'm just going to say, thank you to all of you taking the time, bringing your background, and putting clear thought and logic together to help us come up with how we can really make a positive difference here. So thank you.
Thank you.
Thank you for having us.
Sorry it has to end, but I guess it does. Thanks a lot, Iklok. Thanks, and thanks to all the Berkeley team for putting this together. And this video is going to be on demand. So for all of you that will either want to revisit it or share it around, please invite your friends to take a look. So.
All right, fantastic. Thank you. Okay,
Thank
bye.
you.
Take care.
Bye.
Yeah.